Alright, so in this video we're going to go over codominant traits. And codominant traits, that's basically where, think about it like the term co-captain. Both people have a role in leadership, so you will see both. What that means is that when you have your dominant and recessive trait, they will actually go together, so you will see two distinct traits. So let's use our example. So in the example we're going to be looking at, we're going to look at feather color. We have black, the allele for black feathers. We have an allele for white feathers. So if these are homozygous, they'll be big B, black, little b, white. But if they are big B, little b, they are going to be erminate, I think is the way it says, which basically is a fancy way to say black and white. Now, there are different ways you can write out codominance. So you can use the big B and the little b, or you can do like C meaning codominant and then the color. So like CW or CB and then CW. So you can tell you're working with codominant, and then you can keep track of the colors. And then you know when you have CB, CW, it's black and white. Another thing you can do is just do BW and then BW, or you can keep it this way. I would lean for codominance to do this way, so you remember it. That's also how I'm going to key it out. If you get your answers correct and you do it this way, that's fine, but it'll be the easiest to remember in one of these ways. So let's go to our example. So we already talked about how this B is for black. I'm going to replace this with, I'm going to do CB and then CW for black and white. And then black and white is going to be CB, CW. So in this example, we are going to be reviewing genotype real quick, and then we're going to cross to black and white chickens. So what is the genotype for black chickens? That is going to be CB, CB. White chickens will be CW, CW, because they only have one color shown. And then the black and white chickens will be CB, CW. You can do CW, CB. Alright, so we are crossing to black and white chickens. So our parents are going to be CB, CW times CB, CW. So we have to determine the probability of having a black chick and a white chick. So let's fill out our Punnett square. So we're going to fill out our first parent up at the cross, and then our second parent down. So CB, CW, CB, CW, we pull down, we pull across. Same thing as the Punnett squares we did yesterday. The only difference is now our heterozygous individuals are both colors instead of just one color. So CB, CW, CW, CW. So again, one thing you want to make sure you understand is phenotypic and genotypic ratios, because each day when we learn new ways to use the Punnett square and new types of inheritance, you're going to still need to go back to the basics of how do I do a genotypic ratio, how do I do a phenotypic ratio. So for this one, your genotypic ratio would be 1 CB-CB, 2 CB-CW, and 1 CW-CW. Our phenotypic ratio is going to be 1 black, 2 black and white, and 1 white. So the probability of having a black chick is going to be 25% because it's 1 out of 4. What is the probability of having a white chick? That is also going to be 1 out of 4, so that will be 25. If you need to, one strategy is make yourself a key where you would say, all right, CB, CW, CB, CB, and CW, CW, and you keep track of all the genotypes on one side and their corresponding phenotypes on the other. So this would be black and white, this would be black, and this would be white. So one of the ways you can tell it's a codominance problem is because you have two colors, and then your heterozygous individual will show those two colors. If this was, say, for example, dominant and recessive, the individual would either be black or white. There would be no option for black and white.